the relationship between lines in general. Again, I have a line like this, okay, and I have a line like this. What is the angle between them here? This angle can be anything. This is maybe 30 or 40. Okay, this is a general case. This is a general case. Okay, sometimes the two lines are parallel and they have exactly the same slope. Okay, the angle between them is 0. There is no angle between, they're exactly the same slope. So in this case we call them parallel lines. Okay, in this case, if this has slope called m1, okay, and this has slope called m2, then m1 equal m2. So for any parallel lines, the slope of the first line is equal to the slope of the second line. Clear that? The third case is when I have a line like this, and then the second line is exactly has 90 degrees between them. The angle between them is 90 degrees. So we call this perpendicular line. Perpendicular lines. Okay? In this case, what is the relationship between the slope of this line and the slope of this line? The relationship between them is m2 is equal minus 1 over m1. You do two things. You change the sign. So if this is positive, this will become negative. If this is negative, this will become positive. The other thing, this become upside down. Okay? You invert the fraction. How do you invert the fraction? For example, if m1 is 2, this will be minus 1 over 2. If m1 is 2 over 3, suppose m1 is 2 over 3, what will happen? It will become minus 3 over 2. Okay? So let us have some examples here on that. Okay? Some examples on perpendicular lines. Suppose m1 equal to 2 over 3. m2 will be what? You change the sign. This is positive, this is negative. So immediately this should be negative. And then you invert the fraction, so it becomes 3 over 2. You do two things. You change the sign and you also invert the fraction. Right, another example for this. Suppose I have m1 equal to 4. m2 will be minus, because this is the first one is positive. And then 4 become, of course, this 4 is what? This 4 is 4 over 1, right? Yeah. So 4 over 1 become here 1 over 4. Clear? So you do two things. Another example. Suppose m1 is equal to minus 5 over 7. M2 will be 7 over 5. Yes. It become positive and also you invert the fraction. Okay, got the idea? And sometimes when a new question, a new example you don't see, you really get confused. I'm trying to exhaust all the possible examples. Minus 1 over 5. Or positive 1 over 5. What will be M2? Minus 5. Minus 5. Clear? Because this is 1 over 5, this becomes 5 over 1. This is positive, this becomes negative. So these are all examples of the perpendicular. But now let's go back and understand, the question. The question, I usually give you two lines. I give you two lines, and then I ask you, are they parallel or perpendicular or neither? Here, it means neither parallel nor perpendicular. And sometimes in the question I say neither. Neither means what? Neither means not parallel and not perpendicular. Not this and not this. So you have to get the slope here, and compare. If one of them is minus 1 over the second, it's perpendicular. If they are equal, it's parallel. But if this rule does not happen and this rule does not happen, it means what? It means it is neither parallel nor perpendicular. Let us see an example. Suppose I have a line passing by, I call this line L1, passing by 2 points. This is a point and this is a point. Another line, I call it L2, also passing by 2 other points. Now I'm asking you, what is the relation between these two lines? Are they parallel or perpendicular or neither? What you have to do is to get the slope of this and get the slope of this and compare. Okay, so let's get the slope of the first line, which I call it M1. This is called M1. M1 has a rule based on given 2 points. When you're given 2 points like this, how do you get the slope? There's a rule for this, right? The slope is y2. Remember that? y2 minus y1 over x2 minus x1. But where is x1, y1, y? This is the first point, x1. This is y1. This is x2. This is y2. You know, writing these down here help you avoid making mistakes when you put the formula, when you substitute in the formula. So it's good after knowing this is the first point and this is the second point. But this is x1, y1. This is x2, y2. Okay. Let's now substitute. This is equal what now? y2 is what? 3. And then minus y1, which is minus 3. So minus 3 would be plus 3 after that. Okay. So this is going to be 3 plus 3. And x2, which is 4, right? Minus x1, which again minus 2, right? Which is again going to be 4 plus 2. Again, it's going to be 4 plus 2. Okay? So now what is the answer now for this? 6 over 6, right? So that's 1. 6 over 6, which is 1. Okay? So that's the first slope. Let's get the second one. Same thing. M2 is going to be, suppose again this is called x1, this is y1, this is x2, this is y2. Any question about the choice of these points? And I choose the first point here and second point here. If you choose this is the first and this is the second, there is no problem. You still get the same slope at the end. It doesn't change. So anyway, y2 is going to be 7 minus 5 divided by x2 minus x1, which is 5 minus 3. So it's again 2 over 2, which is again 1. So here, obviously, the two slopes are equal. This is 1, and this is 1. So you can say simply that the two slopes are equal, and that's why they are parallel. Okay, since M1 equal M2, then L1 is parallel to L2. Okay, that's how we write parallel. You can use this symbol here. This symbol here means parallel. This one means parallel. So this line 1, this is line 2, and they are parallel. Okay, if you don't want to do that, you can just write here parallel. Okay, parallel. Okay, any question about that? Okay. What is the symbol for perpendicular? Anybody knows what is the symbol I should use for perpendicular? How does it look like? Yeah, perpendicular looks like this. Okay, we finished this question. Perpendicular, okay, looks like this. Okay, so that's like a T, but it's it's inverted also.